Hello, welcome to the lecture. And today we will discuss on the conditions required for most efficient or economical circular channel section. So we have done the conditions for most economical rectangular section. We have done for most economical trapezoidal section. So in today's class, we focus on the most economical or efficient circular channel section. There is a peculiar problem in circular channel section. In all the two previous cases, when we are doing most economical condition, first thing is the discharge should be maximum. Economical means the channel should carry maximum discharge. In the rectangular channel section, based on that we derive. How? For example, if discharge is to be maximum, then based on continuity equation, Q is equal to area into velocity. The area of flow section, assuming it as constant, discharge will be maximum if velocity is maximum. And you use either Cheggy's equation or Manning's equation, V is equal to C root Rs. Naturally, C is a constant, Chegg is constant. S is channel bed slope, which is also a constant. So what factor R depends upon? R. What is R? The hydraulic radius. So if R is maximum, naturally V is going to be maximum. Then what is R? R is equal to A by P. When R will be maximum, because we started A is constant. So if A is constant, when R will be maximum, then P will be minimum. So this is the condition on which we derived the equations for rectangular and trapezoidal channel section. For maximum discharge, the condition is the wetted perimeter P should be minimum. That is what we have done. Look at the channel, rectangular. The shape, if you take it, whatever is the depth of flow, the shape of the flow section doesn't change. It is always rectangular. You take a trapezoidal section, as the depth of flow varies, still it is a trapezoidal section only. It is a trapezoidal section. But now you take a circular section up to half if the water is filled. We call it a semicircular section. If it is less than that, y is less than the radius of the circular sieve, its shape is different. At the center, it becomes semicircle. Still, if it grows naturally, its again shape is different. So the shape of the area of flow section is continuously changing with the depth of flow. As the shape of the area of flow section is changing continuously with the depth of flow, the area of flow and wetted perimeter are very much dependent on y, the depth of flow. They are no more basically. You cannot treat A as constant. A is a variable, P is a variable. Both wetted area and wetted perimeter, both are variables. But in the previous cases, that A is constant. What is variable there? Only P. Wetted perimeter is the variable. That's how we did in the previous cases. But here, both are variables. In such a case, what to do? That is how we have come out with a solution for this. wherein we derive the conditions separately for maximum discharge and separately for maximum velocity. So that we will take it up straight. So today's lecture focus on conditions for maximum discharge and maximum velocity in case of circular channel section. This is our problem. So let us take the circular channel section. Conditions for most efficient channel section. I take a circular channel. So if I take it, this is the center, right? This its diameter is some capital D. Now the water level is up to here. So this I call it as Y. Now if you see, this shape of the section is like this. Suppose if the water is up to here, again this is different. Suppose if the water is here, this is semicircle. If the water is up to here, again here, what is happening? The boundaries are converging. If the water level is here, then naturally it is converging. As the boundaries are converging, right, the shape of the area of flow section is varying. Therefore, both wetted area and wetted perimeter both are variables. Area cannot be treated as constant. That is what I wish to bring to your notice. That because of that, we have to derive separate conditions. One based on maximum one based on maximum discharge, one based on maximum velocity. This is the first thing. In all the previous cases, only we did for this, assuming that if it is done, automatically it is efficient. That is what condition is. Now for this, I will take it. Let us see. Maximum discharge. Once again I am drawing the section, circular channel section, right? And take this as the center. Now this is the water level, right? I call it as A. B is the water surface. I put it like this, right? Then if that is the case, how to do it? And this is the center. So first thing you do is join it to the center, these two. And you know, if D is the dia of the circular section, radius is equal to smaller. So this is smaller. Then next, this is depth of flow, y. The depth of flow is y. Then next, the angle subtended here at the center. Once again, I am showing it a bigger figure. So this is one, this is one, this you take it other. So this is O, this is A, B, and the other one is like this. This is the circle, right? This is how you should do. So this angle is 2 theta, right? This is R, this is R, this is equal to Y. So now if I separate it, naturally this angle is theta, this side is also theta. Okay, right. Then naturally, if I call it as some D, and this is here C, what is OD is equal to? Can you tell me OD is equal to R cos theta, and BD is equal to R sin theta. Keep it aside. Now let me go into the problem. So first thing is if I take it, for example, the discharge means Q is equal to A into C into root RS. That is equal to A into C into R is nothing but A by P into S. Right? If now I take it, C into this, if it goes inside, A cube by P into root S. So this is constant. This S is also constant. So Q is maximum if A cube by P is maximum. Right? This is next. So then naturally, for maximum of A cube by P, what is the condition? D by, what is the variable actually? The only variable is now theta. D by d theta of A cube by P is equal to 0. So if I do that, then what I am going to get? See, denominator into A cube means 3A square. Am I right? Into dA by d theta. Am I fine? Minus A cube into dP by d theta divided by square of the denominator P square. It is equal to 0. That is equal to P into 3A square into dA by d theta. Theta it is. Theta minus A cube into dP by d theta is equal to 0. A square, if I cancel A square throughout, then what will happen? So it is 3P into dA by d theta minus a into dp by d theta is equal to 0. This is what we can get it. So this is the first thing. Now our problem is, what is this P, what is this dA by d theta, what is A, what is dA dP by d theta, that we have to substitute. So now come to the problem. Again here itself I will draw the figure. Any number of times you draw, nothing wrong, but you should understand. So this is Y, this is O, this is I mentioned OB, this is C, this is D or D I mentioned. So this if I take it, right, this is R, right, this angle is, this is theta, this is also theta. So if I take it like that, then what is basically the perimeter, what is the area we have to find out. So if I take it, actually perimeter P is equal to it is only perimeter this part only, am I right? If I take it, it is theta by 2 pi into theta by 2 pi into basically this angle is how much subtended, actually 2 theta by 2 pi into 2 pi r. This is generally the perimeters for sector, actually. If I take the sector 2 theta by 2 pi into this, so 2 pi will cancel, so it is equal to 2r theta. This is first one. Second one, so therefore what is dp by d theta? 2r. Closed. This is one part. Then second part, what is a? A is equal to, right, area of sector O A C B O minus area of triangle O A B. So if that is the case, what is the area of area of what is the formula for the area that we can write? Actually the area of the thing is nothing but it is as simple as only thing is we can write straight away the sector area is equal to 2 theta by 2 pi into pi r square minus area of triangle. Triangle is what? Half into, right, the vertical. Vertical means what is that vertical? That OD into base. Base is what? AB. So it is 2 theta by 2 pi into pi r square minus half into OB is r cos theta into 2r sin theta. This is the thing, right? This is what we have. So if that is the case, then naturally if I take it, so here pi will cancel, right? 2 will cancel. So this is nothing but r square theta minus, right? This is 2r cos theta sin theta divided by 2. So this is nothing but r square theta minus uh, r by 2 into 2 cos theta sin theta is nothing but sin 2 theta. So therefore it is basically what we can write, it is r cos theta into basic r square. So r square into theta minus sin 2 theta by 2. This is the area.
So now what we want is just dA by d theta is how much. So what is dA by d theta? Actually, for this derivation, you don't need to derive all this. Straight away, you can write this. Straight away, if you can write it, from that you can go ahead. But only to show you what is the thing that I have done it. So what is dA by d theta? R square into theta is minus 1 minus sine 2 theta means cos 2 theta into 2 divided by 2. So it is nothing but r square into 1 minus cos 2 theta. So this is the thing. So we found what is A, what is dA by d theta. Now what is our equation actually? The equation already we have done. It is 3 into P into, our equation is 3P into A square into dA by d theta minus a cube into dp by d theta is equal to 0. So if that is the case, or divide by area, it is 3p into dA by d theta minus a dp by d theta is equal to 0 by after dividing by a square. So therefore, now put it 3. What is P is equal to? P is equal to what we have done. If you remember, P is equal to 2r theta. That is first thing. What is dA by d theta? R square into 1 minus cos 2 theta. This is first term. Minus what is A is equal to R square into theta minus sine 2 theta by sine 2 theta by 2, right, into what is dp by d theta, 2r is equal to 0. So if I do it, 3 into, right, it is if I do it once again, 3 into 2r theta, once again recollect it, r square into 1 minus cos 2 theta is for dA by d theta minus r square into theta minus sine 2 theta by 2 into 2r is equal to 0. So now I will try to simplify it. How can I simplify it? So this is r, this is r square, this is r square, this is r total r cube. If we can remove, I can remove r cube, divide by r cube. Therefore, how much it is remaining here? 6 theta, right, into 1 minus cos 2 theta minus r square gone, r gone, 2 into theta minus sine 2 theta by 2 is equal to 0. Right, this is the what is again what we can simplify. I can divide by 2. So if I divide by 2, 3 theta into 1 minus cos 2 theta minus theta minus sine 2 theta by 2, 0. So still if I simplify it, then what can I do? Just let me see. 3 theta minus 3 theta cos 2 theta minus theta plus sine 2 theta by 2 is equal to 0. This is the first thing. Then still what can I do? 3 theta minus theta is 2 theta. 2 theta basically, then minus 3 theta cos 2 theta plus sin 2 sin 2 theta by 2 is equal to 0. This is our final thing. So that means 4 theta minus 6 theta cos 2 theta plus sin 2 theta is equal to 0. So this is the final equation. What is our final equation if you see? Then again if I see finally how much it is coming, 4 theta, right, minus 6 theta cos 2 theta plus sin 2 theta is equal to 0. If you do up to this, then solving this equation,
Therefore, we have derived the condition for what you call it as a 2 theta is equal to 308 degrees. That is, theta is equal to 154 degrees. That is what we have discussed. So, what in that case, y is equal to, we have derived also for y, and y we have kept it as 0.948 diameter. So this is one we have derived. So the second condition for that, normally it is always R is equal to A by P. What is R? R is equal to hydraulic radius A by P. What is A? A basic, A is equal to R square into theta minus sine 2 theta by 2 divided by P is equal to, yes, due to R theta. So if I cancel R, then it is R by 2 into theta minus sine 2 theta by 2. This is the thing. So now we can go ahead with that, substituting what is theta, which is 154 degrees. But we should write in radians. Therefore, then how much it will be? Theta is equal to 154 into, how we will write actually for this, uh, when we are writing it, how we have to write it is pi by 180. This is how we will write actually for this. So if I write like that, the things basically, then in that case, how much it will be? It will be 2.678 radians. Therefore, R is equal to R by 2 into, it is 2.687 minus basically sine 2 theta means 308 degrees divided by 2. So if this I solve it, it is going to be 0.573 R, which is R is equal to 0.29 T. So this is the second condition. Therefore, what are the conditions now? What are the conditions for most efficient circular channel section
For maximum discharge, there are three conditions. Number one, 2 theta is equal to 308 degrees, or theta is equal to 154 degrees. Second condition, y is equal to what we have done. It is y is equal to 0.948 d. Some people will write it as 0.95 d, where d is the diameter. Then third one is r, hydraulic radius. This is the depth. This is hydraulic radius, and this is diameter. Or this is 0.29d. So these three, if you remember, that will be fine. So we will stop this lecture at this. So today's lecture is mainly to derive the conditions for most efficient circular channel section, keeping in mind to carry the maximum discharge. Theta is equal to 154 degrees, y is equal to 0.95 times the diameter, and hydraulic radius is equal to 0.29 times the diameter. So we will stop this lecture here and meet in the next lecture with the second part of this basically circular section, which is nothing but actually we have to do for maximum velocity. So that we will do in the next lecture. With this, we will close this lecture today. Thank you very much.
Like, share, and subscribe. Hit the bell icon for more updates.